Hello student, welcome to all of you in the next physics lecture, chapter number 2, mechanical properties of fluids. This is the video number 17 and myself, Rajesh Legat, physics teacher. Now we have to see here the next point, the surface energy and surface tension. Sometimes in your exam ask, define the surface energy, give its unit and dimension, and also define the surface tension, also give its unit and dimension, so that we can explain these two terms, surface energy and the surface tension. First we have to see here the surface energy. What is the definition of the surface energy? The potential energy per unit area of the liquid surface is called as the surface energy. It is very simple one. Potential energy per unit area, surface area of the liquid surface is called surface energy. And so that we can write here surface energy is equal to potential energy upon its area. Then the SI unit of this surface energy is nothing but joule per meter square, because you know that energy is measured in joule and area is in meter square. So that SI unit of surface energy is joule per meter square. Then its CGS unit of surface energy is ergs per centimeter square. CGS unit of surface energy is ergs per centimeter square. Then also we have to find out the dimension. We cannot directly write the dimension. We can solve this, how it can be this dimension of the surface energy. Therefore, the surface energy is nothing but the energy, potential energy upon its area. Then we know that the dimension for the energy L2 M1 T minus 2 in square bracket, and also we know that the dimension for the area is simply length into breadth, so that L2 M0 T0. So that this L2 L2 get cancelled and the dimension of that surface energy are L0 M1 T minus 2. This is the dimension of surface energy. In MCQ, these dimensions are asked sometimes. Then we have to see the next terms, that is the surface tension. This is also very important in that chapter. The surface tension we have to study it very well. Then what is the surface tension? It is denoted by the letter T, capital T. Surface tension of a liquid is defined as the force per unit's length, acting at the right angles to the imaginary line drawn to the a free surface of liquid. This is nothing but the surface tension denoted by the letter T, that is equal to F upon L, because this is the simply force per unit's length. You can remember this sentence for the surface tension, that is the force per unit's length, that is the F upon L. Surface tension of liquid is defined as the force per unit's length acting at the right angles to the imaginary line drawn to the free surface of liquid, which is called as the surface tension. If F is the force, L is the length, then surface tension T is equal to F upon L. Then that's unit and dimension also very simple. SI unit of the surface tension is Newton per meter, because you know that force is measured in Newton and length is measured in meter in SI unit. So that Newton per meter is a SI unit of this surface tension. Then its CGS unit, simply that is the dyne per centimeter. And its dimensions, you can also solve this, because we know that the surface tension of force L1 M1 T minus 2 and length, that is nothing but the L1. L1 get cancelled and simply L0 M1 T minus 2. This is the dimension of surface tension. You observed in these two terms, that is the dimension of the both these terms, surface energy and surface tension, which are the same, and that's are the L0, M1 and T minus 2. So that we can derive the relation between this surface tension and surface energy, they must be equal, because the dimension of both these quantities are same. So we also see here this relation between them. The surface tension is equal to surface energy. Then we have to see here the next point, which is always asked in your exam. what is the relation between the surface tension and the surface energy. We have to see here definition, unit and dimension. Both the dimension of the surface energy and surface tension are the same, so that both these quantities are the same, and this is the relation between the surface tension and surface energy. We can see with the suitable examples. Now, in this relation between the surface tension and surface energy, we have to consider here the rectangular frame A, B, C, D in the form of a wire. In the form of wire, we have to consider a rectangular frame A, B, C, D. This is the open rectangular form in the form of the wire. Then this frame, on this frame, the wire PQ, a piece of the wire PQ, which can be slide on this frame ABCD. Suppose the piece of the wire PQ having the length L, which can be slide on this open rectangular frame ABCD. Then this rectangular frame, which can be held in horizontal position and dip into the soap solution. You know that this soap solution, and in that soap solution, this frame, open rectangular frame, which can be deep into that soap solution and taken out. Then the soap film A, P, Q, B will be the form, and which is as shown in figure. If this open rectangular frame, on that small piece of wire PQ is slide on this, and this APQB frame will be held in horizontal position and deep into the soap solution and taken out, then you can see that the soap film APQB will be the form, which is as shown in figure, that portion. This is the soap film APQB. Now, due to this soap film, the force F will be exerted on this wire. Due to the surface tension, the force F will be act on this wire PQ, and this total force act on this wire PQ, which is given by this F is equal to twice T into L, where T is the surface tension of the soap solution, L is the length of this wire PQ, then force exerted on this wire PQ, which is given by the 2TL. What is this 2 factor arises? This reason is very important, because you can see that this is the board, and the one side you can see only the one sides, second sides you have to, the back side you have to not see. But the soap film you have to observe, then this is the transparent, and so that the both sides you can be seen, and therefore because of this transparent surface, soap film has the 2 faces, these 2 factors arises, and so that the force due to the surface tension act on this wire PQ, which is given by F is equal to twice T into L. This 2 factor arises because the soap film has the 2 faces, it should be transparent. Then in this process, suppose that wire PQ, which can be pulled in outward direction, this wire PQ, which can be pulled in outward direction through the small displacement x, then the work should be done, and this work done is given by, this is the mechanical work done, and which is given by, we know that very well, the work done is nothing but what? Which is the product of the force into displacement, and therefore we can write here W is equal to F into x. This is the force and this is the displacement x. Then we know that the value of this force is nothing but what? That is the twice T into L. Then substituting instead of this F, W is equal to this twice TL here, twice TL, and into displacement x. This is the equation number 2. Now, in this process, the additional surface area is created in this case, and this additional surface area is nothing but what? This is the length and into the breadth, therefore L into x. But again, this 2 factor arises because of soap film has the 2 faces, it should be transparent, and therefore the additional surface area which is created in this case, which is given by A is equal to twice L into x. And therefore, if you have to take this ratio of this equation 2 and this area twice L into x, that is the mechanical work done per units area, which is given by 2TLX, and upon the area, that is the simply twice L into X. Then you can see that 2 get cancelled, LL get cancelled, XX also get cancelled, and remaining terms it should be T, and that is nothing but the surface tension. But what is this W upon A about this? Work done is always in the form of the energy, that is the potential energy, and therefore we can, instead of this work, we can write here the potential energy per unit surface area, and this is equal to T. Now see here, instead of W, that is the work done, which is always in the form of the potential energy, therefore instead of work done W, we can write the potential energy upon this surface area, and this is equal to T. Then what is meant by the potential energy per unit area? We can see here the surface energy is nothing but potential energy per unit area. Therefore, instead of this potential energy per unit area, we can write the surface energy, and this is nothing but the surface energy, and T is nothing but the surface tension. Surface energy is equivalent to the surface tension. This is the relation in between the surface tension and surface energy. This is very important. What is the relation between surface tension and surface energy? You can understand well. Okay, thank you.